Hello guys, this is Sri. So in this video, we are going to see about um, the trouble. This is kind of a troubleshooting session on the blocking transactions. So let me tell some real-time example. You may get some alert related to the open transaction or row logs. So when you log in and check, you may see some updates or deletes which are running long time, but that may be a very simple update or delete statement based on the primary key. It will be the quick one, but for some reason it is running for a long time, and even it is not completing for some time. So did you ever face this kind of scenarios? And so for this week, this session will be helpful to understand what is happening in the background and how to find the blocking statements exactly. Okay. We are going to see two methods to identify how to identify the blocking transactions. One is with the performance schema, and the another one is using the general log. Okay, so we will see that. So before starting with these two topics, I would also give some overview about how this happens, and how to identify some basic informations to get into that. Okay, so I have only one server. You can see this host name is MySQL one on all these four sessions. Okay, all these four sessions. I just logged in a single MySQL instance, but I created four sessions. Okay, and I am using MySQL 8.0.40 version. Okay, and all these sessions, let me show you. Use 3, and I have created only one table, which is T1, and you can see the data is we have three rows: 1, 2, 3, ID and XYZ. Okay, and show create table. T1 is this one. So ID is the integer and auto increment primary key column. And we have one more column which is name, that is the varchar column. Okay, fine. So we are going to use this table to see this session. And the first terminal is so this first terminal is we are going to use, to create the first transaction, and this second terminal, we are going to create the conflicting transaction. And this third terminal, we are going to use the to see the process list and changing some parameters like updating general log. So for in checking the InnoDB status for that thing, we are going to use this third terminal, and the final terminal we are going to use the to view the general log. Okay, so I just created four terminals for this session. Fine. Now, let's start with so we already have our InnoDB do the row level locking that we already have, right? So previously we have that is MySum that does not support the row level locking, but InnoDB we have the row level locking. So which means whenever the InnoDB tries to modify some row, it will lock that particular row instead of the table. Okay, so for example, let me show the example for this. For example, we have the table T1, right? So let me create one transaction begin. Okay, and let's say I'm going to update uh, T1 set name equal to some value. For example, YY, where ID equal to 2. Okay, so what happens in the first? session, I just created the transaction. We know that MySQL is auto commit. So if I'm just running this update statement, it will automatically commit the transaction when the statement ends. For our testing purpose, I manually initiated the transaction. So in this case, what happened? When I started with begin or start transaction, then I need to manually commit it by doing the end transaction or commit or rollback to end up the transaction. Okay, so now we just started the transaction with begin, and I given a simple update t1 set name equal to yy where id equal to 2, but I did not committed this value yet, right? So let me come to the second session, and here also begin and update t1 set name equal to uh, triple y where id equal to 2, right? So here you can see this update is not completed. It is waiting, right? Because we know, yeah, before that you can see the process list here. You can see this update statement is running, right? So now let me explain. So we already aware that InnoDB does the row level locking. So in the session 1, we already updated the T1 table where id equal to 2. This record is already updated, but I did not committed this transaction yet, right? So I did not committed or roll back this transaction yet. So this transaction is open and this update is still happening, and this block this row, which means this session 1 transaction locked the row id equal to 2, right? So in this case, in the second session, when it is trying to update the same record, I mean the id equal to 2, then it cannot modify that row because that row is already locked by the session 1, right? So in this case, what happened? This update statement will try to occur this row, right? It will keep try until the lock wait timeout. There is a parameter which is InnoDB lock wait timeout. For example, select at InnoDB lock wait timeout. It will wait until this value 50. That is the default value. 50 means that is the 50 seconds. Okay, so now it is clear, right? So first transaction from the session 1 is already running the update, which is already the query is completed, but the transaction is not committed yet, right? id equal to 2, and the second session is trying to update the same table t1 and the same value id equal to 2, but it is not able to, this SQL is not able to complete because the session 1 is already holding the lock, right? Then we get this error, lock wait timeout exceeded after 50 seconds. How it will wait for the 50 seconds, that is based on the InnoDB lock wait timeout. Okay, if we have the InnoDB lock wait timeout 100 or 1000, then this statement will keep try to get the lock until that 100 or 1000 seconds. After that, it will error out. Okay, like this InnoDB lock wait timeout. Now let me come to this process list. This process list was executed when this update is trying, right? Now, yeah, no issues. Let me start this update again. It is still waiting because the session 1 is still not completed. It is keep blocking that particular row id equal to 2. So when we are trying to update from the different session, it is still running and trying to get the lock, right? Now, if you see this show process list command, you can see this update statement. Update t1 set name equal to triple y where id equal to 2. This update statement is from the session 2, right? So this update statement you are able to see in the process list, show process list. But this update is running, but in this kind of scenario, so you may face this in your production systems as well. So whenever you are seeing this update statement, that should be a small one that may based on the primary key, and that is going to update a single row, but it is still keep running with the state updating, right? And if you see the other queries which in the process list, then you may conclude, okay, so this query is running and this is blocking this update. Maybe some alter or maybe some other statement, update or delete statement. If it is visible when doing the long row update, you will get to know, okay, so this query is blocking this update, so this is waiting. You may get some idea. But in this scenario, you can see in the process list, only you are able to see this update statement from the session 2, right? And you can see the other threads which are in the sleep state. This one is in sleep state, this one is in sleep, and this show process list is the current session ID. Okay. I mean the session 3, the same ID. Okay. So in this situation, currently we are doing manually, we are creating the error. So we have this update is blocking. But just imagine about your production environment. You are just doing this process list and you are seeing this update statement is running, keep running long time. But you do not have any idea which one is blocking, right? So, so you need to find which query is conflicting here so that you can fix it, right? So, in this kind of situations, you may see some sleep transaction, but you do not aware which thread is blocking and which queries are run in that, right? So now let's see how we can troubleshoot, how we can approach this kind of situations. Okay. So here the clear-cut fix could be you need to identify which thread. Maybe killing that thread will be fix the issue, but when you are killing that, you killing some thread ID, then you are, I mean, the thread which you are killing, there may be some transactions are open, some queries are executed, that may impact. Okay, so killing that thread is not recommended in these situations. Maybe after some investigation, after speak with your application team, if killing the thread ID will not create any issue, then that is okay. In that kind of situations, that is okay. But if you are just blindly killing some threads which are open, they may executed some queries. In case if you are killing that, that may create the problem. So you need to be very careful on this. Then what would be the permanent fix? You need to identify the query which is blocking and how this transaction is conflicting, and you need to provide all these informations, and you need to work with your application teams or theirs. Then you need to come to fix from the code level. So that is the better thing. I also see some people are just increasing the InnoDB lock wait timeout from 50 seconds to some bigger value. But that is not a best practice because you are just increasing the wait time for this statement. That's it. All right. So identifying the transactions which are creating the conflict and fixing them in the code level would be the best approach to fix this kind of issues. Okay, fine. So now our main motivation on this video is this one, this process list. We can see this update. My update is very just updating only one row, and I can see this sleep. I mean, the I do not see any other queries are running. Then how I can identify the thread which is creating the problem, and how I can identify the queries which are running in the thread and which is blocking. Okay, fine. In our scenario, we already know this is the update statement creating the problem, but just imagine in your product about your production environment, then how we will approach. That is what we are going to see here. Okay, so first I would say, second. First, I would run the InnoDB status output. So for example, here show engine InnoDB status slash G. So here you can see, let me trigger that update again. So currently that update is completed, right? Yeah. So this update is again running. Now pager less. So you can view the output in the like a less format in the Linux command like this. Okay. So I just given the pager less and the show engine InnoDB status. So here you can see this update statement is log wait with the two log stacks, right? And this is the update statement which is currently waiting. Okay, this thread is currently waiting. Then here you can see two log stacks, heap size this and one row log. Undo entry is 1. So you may aware of the undo log, right? I think we already have one video in our channel. So if you do not aware of this undo log, just please visit that particular video. Okay, for the quick overview, so undo log entries, undo log will keep track of the changes when the transaction is in progress, so that if you are rollbacking the transaction, it will MySQL D will apply the previous entry. Okay, fine. So here you can see one row log stacks, and you can see MySQL thread ID 46, which is creating the block. I mean, which is the blocking thread here. Okay, so you can also manually check in our scenario. You can check here like select uh, connection ID. Okay, so here you can see this is the 46, and in the where is the show engine InnoDB status? Here you can see transaction which is active for the 728 seconds, and you can see the MySQL thread ID is 46, and you can find it from the InnoDB status. Otherwise you can also get that information from the if you are using the MySQL and you have the sys schema, then you can also get it from the sys table. InnoDB log waits. Okay, second. Let me trigger the update, and you can see this update is currently yeah, waiting query, which is the update statement. That is the waiting query, and the blocking query is null because currently there is no queries running in the session 1. Okay, this update was run, but it is already completed. I mean, the query is already completed, but the transaction is not completed yet. That is the thing. So as the query is not running in the session 1, you will see the blocking query null here. Okay, if the query is still running there, then you will see the blocking query here itself. But mostly when you are investigating the sleep transactions, you will see the null in the blocking query here. Okay, but here also you can get the blocking process ID, process list ID, which is the 46. The same ID number, we get it from the InnoDB status. We also confirm that this is the connection ID here. You in the schema, also you can get it from the blocking process list ID 46. And also there are few more queries which are available in the internet to find the open transactions, which is the blocking and which is the waiting thread. The customized query you can get it from the internet also. Okay. So usually, yeah, to getting those IDs, you can visit the InnoDB status. And if you have this schema, then this table is very helpful to find more details about the log weights. So it will give all the process list, database name, and the table name, which index, whether it is primary key or not, timing, when this wait is started, all this timing and this query, and also about the informations about the blocking thread as well. Waiting thread as well as the blocking thread. Both the threads informations you will get it from the table, InnoDB log weights from the schema. Okay. Anyway, this is fine, but still here with this schema also, currently we just get the blocking query is null. So we do not have which query was run and why it is blocking, why my update is blocking. That is still not clear here, right? But we have this process list ID, which is the 46. Fine. So now we need to identify which query was run and how this my update is waiting, why it is waiting, right? We know this process list ID. Process list ID is 46. Okay, fine. Now let's see how to get this information from the performance schema. So in the performance schema, we have the table which is event statements history. Okay, so using that table, you can find all the queries which are already run by using the thread ID. You can get the sequels which are already completed. Okay, fine. So for that, you need to enable the performance schema and also you need to enable the set of instruments and the consumers. There is a table which is setup instruments and the setup consumers. There you need to enable all the counters which is providing the statements and event statements. Okay, for example, where name like statements and also name like event statements, you need to enable all these counters on this both the tables instruments as well as the consumers. Set enabled equal to yes. Okay, so once you enable these counters, it will start to collect the metrics. Okay, it will start to collect the queries. And also here one more thing you need to make sure in this table you need to pass the thread ID. Okay, thread ID is the different from the process list ID. Okay, so here first you need to find the thread ID for that particular process list ID. Then you can pass the thread ID to this table. Okay, so let me show you so that you will understand this better. So here I already enabled this, but yeah, here I'm just executing this again. For example, table. Okay, so I need to choose performance schema and also for the second table. Yeah, so for this you need to, I mean, for this approach, for the first approach using the performance schema, you should make sure you are having the performance schema enabled. Okay, then only you can follow the first approach. For the second one, you don't need the performance schema, but you need to enable the general log for that particular time or that, yeah, we will see that next. Fine. So now we just enable this both the counters and both the instrument and the consumers we enabled it here. Okay, and now I know here I know the process list ID which is blocking, that is 46, but I do not aware of the query, right? But I know the process list ID which is 46, right? Here, and we also confirm that here. Okay, so 46, as I mentioned, this is the process list ID. I cannot pass this to the statements history table. Okay, there I need to provide the thread ID. I need to provide the thread ID. So here I need to find the thread ID for this process list ID. Okay, process list ID is 46. First, I need to find the thread ID for this process list ID 46. Okay, and giving slash capital G, and here you can see I'm running this query again, performance schema dot threads table, where process list ID 46. There you can find the thread ID is 84. For this process list ID 46, the thread ID is 84. Now we got the thread ID, and now you can pass this 84 here, and you can run this statement for the performance schema events statements history table, and thread ID is 84. Okay. So again, we can get the sequels executed from the performance schema event statements history, but we cannot provide the process list ID to this table. So to get that, you need to find the thread ID first from the using the table performance schema dot threads. Okay, there you can find the process list ID, which is 46. So once I run this query, I will get the thread ID. I will get the thread ID. So once I get the thread ID, then I can pass it to this table in performance schema event statement history table 84. Now let me run this statement here. You can see better. Let me give this delimiter. So this is quite lot of information. So better let me just grab the SQL text. SQL text. Yeah, so here you can see you will find all the SQL statements which was executed here in this thread. Okay. So here you can see select star from table, show create table, host name, and select star from T1 begin. Here you can see this update statement was executed. So first begin is executed, begin, which means we are starting the transaction. After that, one update statement is executed, that is for update event set name equal to yy where id equal to 2. But if you see the next statements, commit or rollback or end transaction, which is not executed yet here, right? So you can see that begin is executed. The transaction is started. After that, one update was executed against T1 table, and the filter is id equal to 2. But after that, commit or rollback is not executed yet. So what we can say, this transaction is still open, right? So this transaction is still open. Now you can relate this why my update is waiting in the session 2, because in the session 2 also I am doing the same update statement for the T1 table and where id equal to 2, right? Why this update is waiting now? We can get the from the sleep transaction, we got the process list ID and we pass to performance schema dot threads table, and there we will get the thread ID. Once we pass the thread ID to performance schema event statement history table, then we can get all the sequels executed in the session 1. In that sleep thread. In that sleep thread, what are the statements executed? We can get it. And when we are analyzing that SQL statements, we came to know the begin transaction is started, but it is not completed yet. And there was one update which is locking the ID equal to 2. As this transaction from session 1 is locking the ID equal to 2, that is not allowing the other sessions to modify the ID equal to 2. The same row, because that row is already locked by the session 1, right? So now we are managed to find the statement which is executed in the sleep thread. And we came to know this update was already locked that particular row, and so that the other update from the other session is waiting, right? This is quite useful, but to follow this approach, you need to make sure you have the performance schema enabled on your environment, and also the statements which I executed to enable the instruments and consumers. This needs to be updated. This instruments and consumers related to the statement and events should be enabled. You need to run this both the update statements to enable them. Then this that is simple. You can get the process ID from the InnoDB status or the sys events wait history table, or you can also get it some from the InnoDB underscore transaction table from information schema, InnoDB underscore lock underscore waits table from the information schema. There are few other ways to find the blocking thread ID. But when it is sleep, to find the sequels which are executed and which are blocking, that you can get it from the event statement history table. But for this, you need to enable the performance schema in your environment, and also you need to enable the instruments and consumers. These counters should be enabled, right? So now you got that which query is blocking, and you can take this with your application team. Hey, this update is blocking this update from the different sessions. So we can check the logic behind that, and we can correct it. Okay, fine. So this is one of the approach with the performance schema. The other approach, let me show you with the general log. Okay, the other approach is with the general log. So you may already aware that what is general log, right? So general log means that will record all the activities from the MySQL D for the each sessions, connect, disconnect, and the queries are executed in the flow. Okay. I mean, if the thread one is connected and doing some job, and the thread two is connected doing some job, and thread one disconnect, I mean that exact flow will be recorded in the general log. Okay. So now let's see how to investigate this same thing with the general log. So for example, for that, first of all, I need to enable the general log. Set global general log equal to on. Okay, so I just enable the general log, and here we are going to tail the general log where let MySQL, yeah, so tail hyphen f. So this is the general log created, and now let me roll back here, and here also let me connect, disconnect and connect again. Okay, and the same scenario, MySQL use 3 begin update, yeah, same update statement, and here now connecting again, use 3 begin, yeah, begin, and the update statement triple y, right here, triple y, you can see this update is waiting. And same thing, now, yeah, so now you have the when you are checking the process list, you have some alert or something, or someone is escalating you. Hey, this update is running long time. So now you can see this update is running in the process list. Now the second thing how we are going to see with the general log is let's say you have already enabled the general log. So now you are tailing the general log, or yeah, you are just trying to find the information from the general log. For example, so here we know that sys, or here you can see this blocking thread is blocking process ID is 50. You can also get it from the InnoDB status and the other information schema, right? So here the blocking PID is 50. Okay, so let me start this update again. 50, and the show process list, you can see 50 is in sleep state, and you can see the update is running with the 51 thread process list ID is 51, and the blocking one is 50, right? Now let's say if you have the general log, you can see you can just check the 50 thread ID. Okay. So this is the ID, right? This is the ID. And here you can see this 50 is starting here. Okay. So 50 is connected at this time with the rooted localhost and they're using the socket. And once the 50 is connected, you can see here it is started the transaction query, right? It is started the transaction with begin and the 50 is running on update. T1 set name equal to YY where ID equal to 2. But after that you can see 50 did not run any commit or rollback, right? Then you can see there is the thread 51 connected using socket and here you can see 51, 51, 51. Yeah, 51 is also running. I mean, started the transaction and it is running on update to set some value for the name column for the same ID equal to 2, right? So this is waiting. You can see this update is waiting name equal to y because you can check the flow of the connection here. Already this update T1 table for the where ID equal to 2 is already um, written, I mean already executed within the transaction, but this is not committed yet, not committed or rolled back yet. You can see the flow begin update from the session ID 50, but no commit, no rollback. Then 51 started, 51 also begin update for the same table, same row. This is waiting. This is waiting for the lock wait, right? This is waiting. The reason is in between this, there is begin is executed, update is executed, but no commit or rollback is not executed. So this update is still running and it is holding this ID equal to 2 row. And when the 51 thread connection ID 51 is also trying to update the same row. So here it is blocking, right? So this way also you can investigate why it is blocking and the flow because general log will have the flow of the activities. MySQL D do whatever MySQL D do that all the flow of the activity will be recorded in the general log. So by analyzing that general log also you can easily investigate this kind of issues. So here, yeah, still you can see this update is running. Now whenever do commit or rollback, let's say commit, then it will complete, right? Because whenever this transaction, I mean, the row is holded by the session one, when that release, when I'm doing this commit or rollback, this row will be released. And when it is released, this transaction from session two will be uh, taken. I mean, it will be worked. It will occur the row log and it will work. Fine. So here you can see again that update is then when we have the commit, it is done. Fine. So we already aware of the row lock and InnoDB does the row lock, but main motivation of this video is how to investigate when the transaction is running long time and the sleep thread is blocking that. So that is the main motivation of this video. Whenever the sleep thread is, when if you see the other statement, then you will easily understand, okay, this query is running and this is blocking. That's it. But when the sleep thread is blocking your transaction and creating the row lock issues, lock wait issues, then how to investigate? That is the main motivation of this video. So you can do that with the performance schema and general log both will be the helpful. I think we can also approach this with the MySQL shell. Let me check for that. Maybe yeah, I will go to it and I will make one video for that as well. If you have something there, okay. So again, yeah, it is quite long time I think. So hopefully I am also trying to keep engage my channel. Looking for your topics, recommendation, and valuable feedbacks, and share this video with your friends who is learning the MySQL, who are in the MySQL field. And your topic recommendations are always welcome. I am really looking for the topics from you guys. Thanks for watching. If you did not subscribe my channel yet, please do that and share with your friends. Any recommendations or feedback, please do that. Thank you.